Hello to everyone on the line and joining us today for this webinar. We will get going very shortly. We'll just give people a bit of time to dial in and join us. In the meantime, it would be brilliant if you could let us know where you're joining us from today. So if you could use the chat function on your control panel and just type in and let us know where you're joining us from, that would be brilliant. We tend to get a lot of participants from Australia, but also from Asia. So it'd be brilliant to let us know if we're getting people from the cities or some rural locations, as well as if we're getting any international attendees. So yeah, please do let us know via the chat function where you're joining us from, and we will get going with the webinar very shortly. From Norway. Wow, we thought we wouldn't have any European join us, but we have. Hello to John in Norway. Thanks for joining us so early in the morning your time. Sydney as well, brilliant. Hello, I'm in Sydney too. Nice to meet you. Newcastle, Denmark. Wow, we've got a couple of Europeans. Wonderful to have the international audience with us today. Thanks for letting us know where you guys are joining us from. We will get going with the webinar now. So hello, my name is Holly Baldwin. I'm from Informa Corporate Learning. I'm delighted to be the co-host for this webinar on sludge and sediments in marine fuels. We will go for about 20 minutes in terms of content with this webinar, and then we will do a Q&A session where Keith will answer as many questions as we possibly can. So please, 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 as we go through the webinar, please do use that chat function or the Q&A function to ask us any questions you have as we go along, and we'll get to as many of them as we possibly can. But in the meantime, I want to welcome Keith Forget. Over to you, Keith.
Thank you very much, Holly. Good morning, good afternoon, everybody. We've got a nice dull morning here, so no jealousies on your part there. We're going to talk for the next 20 minutes on something that I've been involved in for decades, and that is sludge in fuels. The only slight difference that we're talking about today is the 0.5% sulfur cap fuels and the sludge problems that it is generating. We'll go through that. It's a huge subject and 20 minutes can't cover it, but we will cover the salient points, and hopefully you will, it'll stimulate some questions and maybe inform at the same time. So we're going to talk about what is sludge, what are sediments, their impacts on fuel systems, impact on engineering staff, how it should be prevented by the suppliers, and during that we will look at the key weaknesses of ISO 8217 that unfortunately predispose these fuels towards sludge, manufacturing practices that can result in deliveries that appear to be on spec when they're made and then go off spec, meaning they were off spec from the beginning. And then can it be avoided? And I've used two terms here: is what should you do versus what actually can you do. So you can have all sorts of debates over what is sludge. Sludge generally refers to the black sort of materials you get in black fuels. It's associated with asphaltenes. Sediments, that word tends to be used for non-residual fuels like gas, oils, diesels, etc. And so on. The two issues, if you look at them separate, they are quite different. The problem that we have is that they're used interchangeably. People refer to sludge, sediments, wax, all that sort of thing. And so from a root cause investigation perspective, you have to sort out what are we actually talking about. Right, the impact. Sludges are invariably, when we're talking about black fuels, are invariably an agglomeration of the asphaltenes caused by a number of different mechanisms. And it's in a fuel that is blended from residues, what I refer to as refining residues, and diluents. And I've used the word diluent deliberately rather than distillates, because today's fuels contain a number of different materials that wouldn't normally be regarded as distillate fuels. Let's be very, very clear. These have the potential and have immobilized ships' power systems. So they represent a major risk to the ship and to the life of people on board. If you put the ship at risk, you invariably put the people on board at risk as well. And the other one that people often forget about is that these are concentrations of some of the most toxic compounds that you find in residual fuels. Now, marine fuels are not safe. They contain a lot of toxic materials. Well, when you have a stability issue and you have sludge, the sludge contains generally all the nasties that are there to have. So handling it is an issue. So it enhances the health risk of using fuels. And the problem you've got with sludge is it's such a pervasive problem on the ship that you're hot, you've got to get your ship moving, you get covered in the stuff. And it is actually not very good for you. Just to sort of, whoops, let me just go back one. I just want to very, very quickly put onto the camera a couple of examples of some sludge, just so that we're very, very clear. If you could make your images of me bigger for the moment, we'll see this material here. This is asphalt-scenic sludge. Now, the issue here, or the incident, this is about 35 years old, from a ship that started its voyage in Singapore, heading for South Africa to pick up coal, and didn't make it. Well, it didn't make it under its own power. It had to be towed into Durban to have the fuel system cleaned out. This image here is a sludge, well, hang on, is a sludge that's about 18 months old, so much younger. And the lumps that I showed you just a moment ago were a bit like this 35 years ago. As you can see, it's very thick, and it doesn't move. Okay, so when your fuel system is completely covered or full of this material, things come to a halt. Okay, you can go back to the screen now. So what I'm just also going to do then, just show you a characteristic of the sludge, because people will often say, oh yeah, just heat it up, move it away. This is not like that. When you've got sludge, you've got a real problem. So this is a sample of the sludge that I just showed you in the pot. You may be able to hear the crackling, and you'll notice it doesn't melt. And of course, that spoon is now way up in the sort of hundreds of degrees centigrade. And you can see it doesn't melt. It's crackling. Now, why is it crackling? It's crackling because it's full of water. One of the characteristics of asphalt-scenic sludge is they're very polar, and they will absorb water. So the sludges are very rich in water. And as you can see now, you've got several levels of water. You've got very large blobs, which give you the big crackles. And then as time goes by, you then start taking out the smaller particles of water. And then eventually it starts to burn. Now, what is also important, and I'll just move this one along a little bit so that it burns, and let's just take it to there. And you'll notice it leaves a really nasty deposit. Now, this is burning in an open environment, and it's having plenty of time to burn. If you imagine these little particles, now I'm not talking about the actual sludge, but the actual particles, that get through to the engine when you've got an unstable fuel and they enter your combustion chamber, they do not burn out. Okay, they form those carbonaceous materials, and they give you all sorts of problems in your piston ring belt, because they will hit the side of your cylinders, probably still burning, when they will immediately go out. They may disrupt the lubricant film, and they certainly will get picked up by the piston ring pack, which will then start to get blocked and can block completely in a relatively small, short period of time. So this is serious stuff. And you cannot, in my view, this sort of stability is the single most important thing of fuels, because it can and has stopped ships in the water. So root causes of these sludge problems. And I'm putting a caveat in here, and that is, and I know this upsets people, but I'm assuming that you keep your fuels completely segregated on board. It has never been more important, but it's always been important. If you're mixing fuels from different batches, the risk of it going unstable, with, I'm talking about residual fuels, of course, the risk of it going unstable is very high. And so if you're mixing different fuels, you're asking for trouble. The main risk is, in fact, these days from the suppliers. And the main problem is ISO 8217, because they use it as a manufacturing specification. It is not, never has been intended to be a manufacturing specification. But people pick it up and they think, oh, here we go. If I follow this, I can make a fuel. And you have this little booklet here, which is ISO 8217. If I was to say, when I was directly involved in this business, the specification for marine fuels was much, much bigger than that little pamphlet I just gave you, because the manufacturing or the manufacturing process is far more complex, and there has to be a lot of procedures and processes in place to make sure that you then have a fuel that actually meets this specification, which is really a selling specification. And the big problem with ISO 8217, well, there's a number of problems with ISO 8217, is that people misuse the data. First of all, they refer to the tables 1 and 2, and they think, as long as I meet those tables, I'm all right, I'm on spec. Well, no, it's not quite like that. It's really important that one understands that the standard includes a number of clauses, one of which is clause 5, and that's referred to essentially as the general requirements. Now, I was involved in working group 6 for the development of ISO 8217 2005 and 2010. So I've got a pretty good idea how those working groups work and how difficult it is to get them to see sense. So if I look at 2012, and there's little changes happened after I left. They don't sound much, but they are fundamental changes that have taken place. So if we look at just a quick reference to 2012 version, and it says 5.2, the fuel should be a homogeneous blend of hydrocarbons derived from petroleum refining. Now, even that in its own right is a little bit woolly, but the working group for 2017 made it even woollier, because they've now said the fuel composition shall consist predominantly of hydrocarbons primarily derived from petroleum sources. Wow. Now, that doesn't sound very different. That is hugely different, because there are you could take a codeine tablet and claim that that is from petroleum sources, believe it or not. So it has completely opened up what some people would think are satisfactory materials that you could use to blend fuels. And that is the root of the problems we have today, because people are using components that were never intended to be included in the specification. Where did this specification come from? The root of this specification comes from company specifications that were developed back in the 1960s and 70s. And they were all based on the presumption that they're looking at distillate or fuels made from distillates derived from refining and residues derived from refining. The idea, the concept of petrochemicals was not part of the argument. And that was the case right up until fairly recently. Recently, I would say 15 years ago. And certainly, whilst I was still active, we were getting more and more problems associated with petrochemicals. So you're either misunderstanding what the specification is actually saying, or you're deliberately misusing the text. And it is a problem. So we're looking at non-petroleum refinery components, petrochemicals, chemicals, not even petroleum, but they do have a petroleum link, pharmaceuticals, catering, etc. They are all appearing in today's fuels. And as I say, the specification just is not suitable for those materials. It was never developed for those materials. And what was more, a number of the test methods were not developed for those materials. This is an oddball one, and it is a difficult one. There's a material out in the market called, referred to as Estonian shale oil, and it is exactly what it says it is. It's shale oil components derived from the shale oil beds in Estonia. Now, there's a couple of heavy streams that really are sort of difficult to dispose of, but of course are very suitable for marine. They appeared in the marine market some years ago. In fact, when the first ECA came in, when the limits were 1.5% sulfur, and it was a very low sulfur product, and it's really cheap. They're almost giving it away. That's not true. They are selling it, but it's very, very cheap. And the problem with this material is it's not normal, and it behaves in a completely random manner. And what is even worse about it is that you can blend a fuel with a proportion of Estonian shale oil, and you can do all your normal tests, even your normal stability tests, and it'll look perfectly okay. It will look perfectly okay. 2 weeks later, you are up to your neck in sludge. Yeah, and there was a number of Baltic ferry companies had serious problems because they were getting quite a lot of this material. And so we did some research, and we discovered that in fact it is peculiar. It does behave differently. It affects asphaltenes in an unexpected way. And the reality is we knew that it was behaving in an odd manner, but we didn't follow that up to find out why and how we could control it. The only way you could really control it is to keep the volume down to very low levels. Now, the problem that you've got is if you look at the front of ISO 8217 and you look in clause 1, you'll see that shale oil streams are considered to be petroleum products. And you think, well, they must have done the work. Well, no, they didn't. I was very much involved in the development of the original, well, British Standard MA 100, which was the precursor to ISO 8217, and before that, with the specifications we used in Shell. And I remember when it was first being discussed, and they thought there was just a view, shale oil, much the same as crude oil. Yeah, we'll include that. Nobody was ever using it in marine fuels. Nobody had used it in marine fuels, but they just thought it must be okay. In reality, we know that Estonian shale oil in particular is not good. And it is mentioned in the IMO and in a document that is floating around at the moment. It's MEPC, where are we? MEPC 74 working paper 8. It's on the table. So we'll see what happens, but really you want to avoid a stone in shale oil at all costs. And this is the biggie. Total sediment age is not a measure of asphaltene stability. Never has been, was never intended to be, but the people in the working group could not be convinced of this. So people, when they're talking about stability, say, oh, well, the total sediment was okay, 0.03, 0.02, something like that. It is not measuring stability at all. And so consequently, you can be doing some work and you can have a situation where you think you've got a stable fuel because you think this test is giving you stability, when in fact it's not. And a common problem is that the limit is 0.1. And so they think if it's below 0.1 or only 0.1, then it must be stable. You can have an unstable fuel that gives you a potential of 0.1 or less. It is important, you have to use an existent. In other words, you do the test twice, and it is the difference that tells you whether you've got a stability issue or not. Now, Holly, I've got a raised hand. Can I respond to that? I've got two raised hands.
Yep, go for it. That was me just raising mine, just testing it out. If you've got a raised hand, yes. I don't know who that would have come from. If somebody's got a question, please do pop it in the Q&A tab or the chat function, and then we can pick it up and address it shortly.
Okay, so maybe we can talk about that just in a few minutes' time, in fact. Okay. And the other problem is that the normal stability tests may not be suitable when fuels contain components from non-refining sources. For instance, I did some work, again, we're talking about 10 years ago, when we were looking at the possibility of looking at ethylene cracker residues as a fuel component. We were looking to reduce the cost of fuel. And so we did a bit of research to see what the impacts were. And on the whole, the report didn't look good. It's not a wonderful material, but it does not behave as expected in stability tests. Plus the fact that ethylene cracker bottoms or residues contain synthetic asphaltenes of their own. Bearing in mind an ethylene cracker source, the feed material is a gas or a light liquid like naphtha. So there's no asphaltenes going in, but you certainly get them coming out. They do not follow the normal rules. And again, I don't think anybody has, or certainly we didn't, spent the time to actually pin down what are the issues. So how do you minimize the risks? Well, only accept, this is what you should do. I'm not saying you can do it. This is what it should be. Is to only accept fuels from suppliers that can demonstrate that they have full control over their supply source chain. It depends where you are in the world as to how easy this is. For instance, if you're in the Singapore area, fortunately, the Singapore government takes a keen interest in what happens in their bunker market, and they want to know if people are messing up. And they've given some pretty good guidelines that their suppliers have to follow. And what is nice about Singapore, if people consistently do not follow the rules, they get struck off. You don't get that anywhere else. So anywhere else, the problems are far more difficult. Certainly the two big sort of problem areas are the ARA area and Houston area. Get them to give you verifiable commitments that they do not use petrochemicals or other chemical streams. If they're not there, your risk of problems are much reduced. And certainly you really don't want to use your stone in shale oil. It is not nice stuff. You can put small amounts in and get away with it. What's small? Less than 5%. If it's more than 5%, you're running into, and certainly 20% is a definite problem. No question about that. Everything that we did when you were at 20%, you had immediate problems. 5%, is it okay for the normal life of a fuel, or will it indeed go off many, many months down the road? We do not know. and that they have proper fuel stability controls in place. And that is not just being able to do an HFT potential. Okay, they need to be able to show you how they control stability for real. Keep on saying that. And then only use non-petroleum products after you've done a lot of work. If you do the work and show that, yeah, it's non-refinery, but we've done this work and that shows that it's okay. Now, it'll never be 100%, but at least there is some evidence that it can be used safely. But when you hear the term, oh, well, it's used widely in the industry, that is not proof of no harm. And this is another one, I've seen less and less of this, but only use suppliers that are willing to investigate if you've got a problem. If they simply say, well, the fuel was on spec, take it up with our lawyers, without any attempt to sort of sit down with you and discover what the problem is, it tells you they don't know what they're doing. And so therefore they don't feel confident in doing it, therefore they won't do it. Can't do it. Or avoid fuels that use heavy residues. If you don't have asphaltenes, you will never get asphaltenic sludge. You might get ethylene cracker sludge, but you won't get asphaltene sludge from normal fuels. So, in summary, there's an awful lot of sludge reports going around, and I'm dealing with an active case at the moment of a serious problem, that could have gone really, really wrong. And there are lots of others that I've heard of, but they don't come in the statistics because you'll get them say, well, it passed the total sediment age, so it must have been okay. Well, as I'm saying, total sediment age is not a measure of stability, and people are hiding behind it and not realizing that it doesn't do it. And let's be absolutely clear. If you just manufacture on the basis of ISO 8217 document, you're not going to make good fuels because it is not a manufacturing specification. And this is the one I'm always saying is, do we actually need a ship to go onto the rocks because of the fuel before this problem is actually taken seriously? Right, there we are. It's 27 minutes, so I'm just a little bit over. As you can probably imagine, there is an awful lot behind all of this that I've been talking about. But in 20 minutes, at least I have sort of scratched the surface. And certainly I'd be willing to take questions. Now, do I go on to the next slide, Holly?
Yes, if you could, that would be great. And Keith, thank you so much for that insight. As you mentioned, it's a topic you could talk on for days, but it's really good to get that background and obviously some of the risks as well. And that last point you made was very pertinent and one that needs to be front of mind. So thank you so much for your time with that. As mentioned, we will get to the Q&A section shortly. So if anyone on the line does have some questions, please do use either the Q&A tab or the chat function to ask those questions. We have had a couple of questions come in, so we'll get to them shortly. In the meantime, just to let everyone on the line know that Keith does run several training courses around bunker fuel blending and advanced bunker operations. And we are delighted to offer anyone on the line today a 10% discount off these courses. Don't worry too much about taking the information down now, as we will be sending out a follow-up email and information. But if you are interested, please do pop us an email at training@informa.com.au, and we can provide you with some more information on them. And we also do run courses in-house. So if you have a team that you think would benefit, let us know and we can discuss that further as well. So on to the questions, Keith. We had a couple coming in, as I mentioned. So the first one I think is referring to the video you showed, obviously, of it not melting. The question is, how is the spoon not hot? Which is a good question.
No, the spoon is hot. It's very hot.
Yeah, very hot.
And that's the whole point, is that if you think about where you get sludge on a ship, it'll be in your tanks, but more likely the issue is in your centrifuges and your filters. And even if you heat those, I mean, you're talking about 100 degrees centigrade maximum. a spoon within, only about 30 seconds is way up at around about 300 degrees centigrade. So it is much hotter, and yet that material is not melting. And it's a characteristic of these materials. It does not melt and flow. So once you've got it, you can't just steam it out or anything. You actually have to physically remove it, or use a powerful aromatic chemical to dissolve it out.
Yeah, you definitely wouldn't want to be touching that spoon, that's for sure.
No. That is not cool.
The next question though, Keith, says, so if the total sediment brackets aged is of no value, why do people do this test?
Oh, absolutely. Oh, you've got my soapbox. As I said, when I was on the working group for ISO 8217, I was trying my hardest to get the two-stage process in place. Let me just, can I, now Holly, you'll have to explain or confirm. Can you have the screen gone black?
It has, yes.
Okay, brilliant. And if I go down here and include yellow.
Are you wanting to show something on like a whiteboard type thing?
My whiteboard normally works. For some reason, it's decided to not work. That's a pity.
Yeah, if you maybe stop sharing the PowerPoint. Oh, there you go.
Yeah, well, that's
this might work.
No, definitely not working.
No.
Okay, fine, no problem. In that case, then I'll have to explain. Right. First of all, hot filtration tests never measure stability as such. Okay, they measure sediment. That's all they do. Okay. But what you can do is, if you do and this is why it was developed, is you do the test in what we call the existent phase. So in other words, you take the sample as it is, you prepare it as per the test method, and you will collect some material on the filters, and you will measure that. And that is referred to as the existent. So that's HFT existent, or sediment by hot filtration existent. Then you do the aging process. Now there's two ways you can do that. One is you hold a similar sample at 100 degrees centigrade for 24 hours, and then you repeat the test. And what you're looking for is the difference between the two tests. So if, for instance, the potential comes out higher than the existent, then you have generated something. Where does it come from? Well, given the material that's involved, it is probably asphaltenes. Now, the question then is, well, what is the difference? Well, I would say, from my perspective, if I'm using a laboratory that I know I can trust, and the hot filtration test is easy to get wrong. You do have to follow the procedures really, really carefully. And assuming I'm satisfied that these people can do it properly, then a difference of 0.03 is an indication of stability issue. Okay. Now, there are a lot of people out there who say, oh, if you look at the precision of the test method, blah, blah, blah. Yeah. I'm talking about decades of experience of this, and 0.3 difference tells you the fuel is unstable. However, if you want to be picky, let's make it 0.5. Then you've got allowed a margin of error. So if you've got a difference between the potential and existent of 0.05, then you know the fuel is unstable. So you could have a fuel, and quite frequently a fuel will come out at 0.01. So if you've got a 0.01 existent and you have a potential of 0.08, say, that fuel is unstable. No question about it. That fuel is unstable, but it hasn't exceeded 0.1. So the people say, well, it must be okay because the specification says it's okay. And that's the problem. The people think that ISO 8217 is absolutely the word. It is not the word. Remember, the working group is largely made up of oil suppliers. Yeah, there are a couple of ship owners represented, but are they experts in fuels? No, and they tend to defer to the people that know, oh, and they're the oil suppliers. And so you do not think that the ISO 8217 is unbiased. It is not. It is terrifically biased. And so by leaving just the potential in, they've made life easier for themselves. Now, there are variations. There's the accelerated test, and that will come out. Again, you're looking at the same sort of difference. If it's anything between over 0.03, you have a stability difference issue. And just because it's less than 0.1 does not mean to say you won't get sludge. It does not give you a measure of how much sludge will be developed. The sort of what you've got today that you refer to as very low sulfur fuel oil, 0.5% sulfur, is not a new grade. Right, back in the 80s, we used to supply in Singapore a product called blended diesel. And blended diesel contained about 12% residue, which is pretty similar to what you're getting today. But it was blended properly. And so, you know, it's nothing new, but you do have to make it really, really carefully. A blended diesel could produce shed loads of sludge, even though it's only got 12% residue in it. So the hot filtration test does not tell you how much sludge you'll get. All it is telling you is it's unstable. There are far more sophisticated tests that you use for stability, which are not currently in the standard. But again, you've got to be really, really clear on what basis do you develop these tests. If you're developing them using just ordinary fuel components, does it apply? Can it be used if you start using ethylene cracker residues? Is it still applicable? Now, there is evidence, real evidence, that it isn't. And that a lot of work, and that's the problem. It is a lot of work to actually develop this kind of method because the variation within the market is huge. Yeah, it is huge. Every fuel is unique. Okay, does that answer the question?
I'm sure it does, Keith. Thank you for that. The next one's a brilliant question. It says, does the move to low sulfur fuels aggravate the issues, especially since the blends can vary greatly across suppliers?
Yeah, absolutely. I mean, VLSFO is a bucket full of worms because all of the normal sort of indicators are no longer there. We are now blending for sulfur. And so what is important to the supplier is what components have I got that have got low sulfur. We're not worried about viscosity or density anymore because we're no longer near those limits. And so they're searching around for components that are low sulfur and so they're focused on low sulfur, low sulfur, low sulfur, and really forgetting the fundamentals of blending marine fuels. So yes, absolutely. The need to go to 0.5% sulfur has aggravated the situation enormously.
Yeah, definitely. The next one says, hi Keith, how do you get rid of a sludge problem once you have it?
And that's the problem. You don't.
$1 million question.
Yeah. On board, there is absolutely, well, it's wrong to say absolutely nothing. There is very little you can do on board. And the problem that you've got is once you start getting a sludge problem, you do not know how bad it is going to get. A classic situation was we messed up on a delivery, this is some years ago, on a Dutch tanker, and they were going through Suez and were going to go around to the east coast of Africa somewhere. And we discovered that we'd supplied an unstable fuel. It was an unfortunate mistake, but we discovered we'd got it wrong. And so we contacted the ship and said, we've just discovered the fuel we supplied is unstable. We suggest that we've made arrangements for you to call into Durban and we'll take it off and we'll replace it and sort things out. How many traders would actually say that? Anyway, they came back and they said, no, it's okay. The ship's doing fine. We've called the ship. They're fine. Everything's okay. And they said, we went back and said, no, it is unstable. And they said, no, it's fine. Honestly, we can't afford to stop. And we said, okay, fine. Give us a call if you have any problems. We will leave the offer open for Durban. 2 days later, we got the call. Okay, and by the time they got to Durban, they were struggling to keep that ship going. What can you do to stop it? Nothing. Once it's going, it's going. You have got nothing on board there that you can use to restabilize it. And even if you restabilize it, getting the sludge back into the fuel is not easy. It can be done, but it's not easy. The only solution to that is to get it off. And then once you've got it off into a terminal that's capable of dealing with it, they can then add, for instance, loads of cycle oil or something to stabilize it. And then if they're really keen, they can leave it sit for a while whilst it all redissolves, or more likely, they will do partial blends into other fuels just to sort of drop the levels, the sludge level and everything. So it's all doable, but you can't do it on the ship.
Prevention is key, definitely.
Okay. Oh, absolutely. Oh, absolutely. You do not want these materials on your ships.
Definitely not. The next one says, does most fuel additive really work on fuel sediment?
No. I suppose I can get screwed for saying that. My experience with additives is they work well when you do them in tests in the laboratory, or they appear to work well, they give you a result. But in the field, once you've got a fuel that is genuinely unstable, you haven't got enough additive there. I mean, effectively, to stabilize a fuel, you can just put a load of cycle oil in, and that will stabilize it. You don't need an additive. Cycle oil would do it, but of course you can't do that. And all of these additives tend to be dispersants, or dispersant based. They're not actually affecting the fundamental chemistry of the fuel. They're just dealing with the sludge, which you might think, well, that's okay if it doesn't block the filters, if it doesn't block the centrifuge, that must be a big thing. Well, it's still getting through to the engine, and it'll still be agglomerating. It's just that the additive stops them from sticking together. And as I said earlier, and I showed you, this stuff doesn't burn very well, and getting it to the engine is probably not a good thing for your engine. And I have seen ships and engines where the whole ring pack has been completely jammed through carbon because of it. Okay.
Wonderful, thank you. The next one says, do you have any recommendations for mobile POLS, quality testing machines?
POLS?
Yeah, poles.
What's a pole?
I haven't heard of that one either. So maybe whoever asked that, if you could provide a bit more commentary on that, and we'll move on to the next question in the meantime.
What I can do is there is a test, a way of doing it. And again, the caveat would be it works with normal fuels. Does it work with chemicals? It's debatable. There is a spot test that you can use. And if you do the test properly, it used to be called the Shell spot test. I don't know what they call it these days. It's available from a company called Zematra. And you can use that. And I've got a test here. I've got a kit here, and it works really well. And if you do that on the fuels, you can get a good idea. But of course, you're doing this with the bunker barge alongside. And as I said before, if you've got a stone and shale oil in it, you won't pick it up anyway. But certainly you can use a certain spot test. It's not like the standard ASTM spot test. It is a spot test. It is what we call a partition chromatography test. But you know, is it affected by these other chemicals? It certainly won't show up as stone and shale oil. And it is too late. Really, you do not want to be doing this when the barge is alongside. You might want to do it to prevent yourself getting a problem, but now you've got a whole heap of problems because you're going to turn the barge away. Yeah, okay. See what the charterer thinks of that. It's a tricky one. the best thing is to only use suppliers that you know how to do it, and they're out there. I mean, for instance, I mean, just a classic example of the work that is not done but is done by others. As you may recall, there was a field trial, end of field trial result announced by Exxon a little while ago, and it was about one of their biocomponents. Now, the way these biocomponents are produced, they're actually very nice products, and you can be sort of fairly certain that they'll be okay, but they still went through the whole process of doing all the testing and a field trial, a full field trial, which are not cheap, to actually give lots of evidence that this stuff works. And this is with a product that is pretty well known and is pretty good quality. Yeah, has anybody done this with ECR bottoms? We did some, and it wasn't good. But I don't think anybody else has. So know your suppliers, and make sure that your supplier gets it right.
Yep, good advice there, Keith, definitely. The next one says, if ISO 8217 sediment tests aren't suitable to identify stability when looked at in isolation, what further stability test methods are recommended?
I would suggest, you don't have to go to the stability test methods. I would simply insist on an existent and potential. So hot filtration, existent and potential. And look at the difference, and you do not want a difference, a positive difference of greater than 0.03 in my view. But if you want to be a little bit more pushy, then 0.5. I can live with 0.5, but 0.3 is already telling you there's a problem. And bearing in mind, it can go the other way as well. And this is where people say, oh, it's no good because you can get a less sludge in the potential, and that's fine. That is telling you something. It is telling you there is sludge in there and it is redispersing within the fuel. That's good. That's normal. So all you need is an existent and a potential. See those results. Now, as I said, all of that works providing you've got normal components. As soon as you start putting chemicals in, then I'm not saying it is definitely wrong, but it may not be right. And what you're likely to get is a sort of false negative, i.e. it looks okay, but in fact it's not. If you get a positive result, i.e. you get a high amount of sludge developed in a potential, then you know you've got a problem. But if you don't have that, as I say, we know this from experience with certainly with Estonian shale oil, and there is an indication that there may be something in there with ethylene cracker bottoms as well. That when you do the test initially, when you've blended, or even when you're doing lab blends, it'll look good. And that in fact, the instability is invisible to the test at that time. Repeat the tests in, let's say, a week's time or 2 weeks' time, and lo and behold, it's failed. Now, the supplier will say, well, when we tested it, it was okay. Well, yeah, it was, that particular result was okay, but because you're using all of these materials, in fact, the test is not that valid. If it goes on.
Good question, that one, definitely. The final question we have for you, Keith, says, to follow up on the earlier question, have there been observable trends on engine failures with VLSFO arising from sludge and sediment issues? Granted, the sulfur cap only became effective last year.
Sorry, could you repeat that? I didn't catch that.
Yeah, so to follow up on the earlier question, have there been observable trends on engine failures with VLSFO arising from sludge and sediment issues? Granted, the sulfur cap only became effective last year.
Yeah, well, the answer is that there are indications. As I say, a lot of the official data only goes on the analysis results, and the total sediments seem fine. Picking up ships that have had sediment problems is far more difficult. Now, BIMCO did a study a little while ago that showed that in fact there were a lot more sediment issues that simply weren't really reported. They didn't compare, and frankly, the one I'm dealing with at the moment, it's an uphill struggle dealing with some of these suppliers. And so I can imagine a lot of people go, oh, just, we'll live with it. The problem is you're living with a problem that could wreck your ship eventually. Yeah, you must not underestimate the potential for sediment and sludge. It is huge potential.
Lovely. We have had another one come in that says, has lube oil compatibility been a challenge for VLS FOs?
Well, I haven't really looked at that, but I don't see that it should be a big issue. I really don't. I mean, I was involved with lubes in a big way. And I don't see anything in VLSFO. I mean, it is not a special fuel. It is a different way of blending. What is special is the chemicals, and there's more and more. So, if you do GCMS on a lot of fuels, you will find that there are some of them will have nothing, but there will be a few out there that you will find styrene in there, for instance, indanes, and various other chemicals that have come from petrochemicals. So they are petroleum derived, can't argue with that, but they're not from petroleum refining. They are from petrochemical processes. And that's my concern with the 2017 version of ISO 8217, that what appears to be a minor change in text has made a big difference to fighting a quality problem.
Wonderful. Well, thank you for that, Keith. That is all the questions that we have had come in. And thank you so much to everybody on the line for joining us. And thank you so much for getting involved with the questions. There's some brilliant questions that have come in there. And I hope it's been a really kind of useful and fruitful exercise for everyone on the line. Again, please do get in contact with us if you'd like more information on the courses that Keith runs. He obviously goes into a lot more detail and has a lot more opportunity to kind of make use of his expertise on those training courses. But the biggest thanks for today obviously goes to Keith. Thank you so much for your time and your expertise. It's been brilliant to co-host with you today, and hopefully we'll get to do it again soon.
Okay, lovely.
Wonderful. Thanks everyone, and have a great either morning or afternoon, depending on where you're from, and we'll speak soon. Bye-bye.
Bye-bye.